Week 12, Lesson 5. Okay, so this particular lesson is on word problems, which again, a lot of people don't like. I get that and I'm sorry, but this is more real life than most things. So the first thing we need to talk about is what degrees, minutes, seconds are. Okay, so if you took 1 degree, all right, and I'm going to attempt to draw 1 degree, but it's really, really difficult because it is so unbelievably tiny. So let's pretend that this is 1 degree. If I divide that into 60 little pieces, each of those pieces is called a minute. Okay, and then if I take one of those and divide it up even further into 60 little pieces, those are called seconds. Okay, and this is what it looks like when you actually write it. This one would be 32 degrees, 45 minutes, 36 seconds. And you're doing this for much more accuracy. And you're going to have to know how to put this into your calculator. So I'm going to switch to the calculator. And when I switch, I'm also going to show you that if you just hit enter after this, you'll get this also in what's called decimal degrees. So this is degrees, minutes, seconds, and I'll show you how to get it into decimal degrees. Okay, so now that I'm in the calculator, I want to make sure you know where to find the buttons that you may need to put things into degrees, minutes, seconds. So before, right, I had you write down 32 degrees, 45 minutes, 36 seconds. I want you to see how to type that into your calculator as needed. So obviously the 32 is the easy part. To get the degree option, you have to hit this little button right here that says angle, which means you're going to have to hit second and apps, and angle, or the degree, is option number 1. So notice on the screen, it now looks like 32 degrees, which is awesome. Okay, next let's go 45. Let's go back to that angle menu, and option number 2, right, is going to be the minutes option. Now, you'd think it would make a whole lot of sense to put seconds in that same menu, but they don't, right? Because why would you do something that makes sense? Why would you do something that makes it easy for students? It's right here. It's teeny tiny and it's green. So if I want to hit 36 seconds, obviously the 36 is the easy part, but I'm going to hit alpha and then the plus sign to get the second marker. Okay. And I hit enter. That's what that is in regular old decimal degrees. Okay, so degrees, minutes, seconds up top, decimal degrees down below. Okay, we're back. Okay, now you may remember seeing this picture before. There will be problems that involve angle of depression along with angle of elevation. Probably the most important part to remember here is that they are measured from the horizontal. That should be a highlighter. Horizontal here, horizontal there. So imagine a horizontal line, and then you're either looking at it from that line down for depression or from that horizontal line up for elevation. All right, and hopefully you're recognizing that those two angles are equal. They are alternate interior angles from geometry, okay? And that will end up being slightly important. Okay, now here, this particular slide that you're looking at is probably the reason why this lesson is sort of confusing at times. I highly encourage you to ask questions about this on Zoom, or if you're an in-person person, ask me while you're in class. And I'll let you read this. Airplanes are always measured from due north and in a clockwise direction. Okay, so let me switch to a pen. Here we go. So this would be considered north, right? And whichever direction the plane is flying is measured from that in a clockwise direction, right? So it could be like up to 90 degrees, up to 180 degrees. This would be to 270 degrees, right? And it can be up to 360 degrees. Okay, now ship bearings are different. Okay, so you have to really pay attention whether the problem is talking about airplanes or about ships. Okay, because ships have 3 parts to them. The first part is either north or south. The second part is an angle that is less than 90 degrees. And the third part is either east or west. Okay, so I'd like you to look at this exact same picture. Let me highlight it over here that we were talking about before. Okay, so let's just pretend, okay, let's just pretend that I'm going to write a number in here. Let's pretend that this angle is 35 degrees from here to here. Okay, if this is a ship instead of an airplane, the first question I have for you is this ship going more north or more south? All right, and I think you would agree it is going more north. So that's why this first part of it would be considered north. Okay, and north is right here. Okay, so now the question is, from north, how far away are you? Okay, so if this part down here is 35, the question is, how far away from north is this ship? So that's why this number would be 55 degrees, right? 35 and 55 make 90. Okay, and then the question is, okay, is from north, you've gone 55 degrees, but that could be this direction or this direction. So is it more towards the east or is it more towards the west? This one would be west. Okay, so let's just sort of reiterate here. If this particular vehicle was a plane, you would say that it's going its bearing is 305 degrees. It's measured from north and it goes all the way around to 305 degrees. But if it's a ship, you have to tell me three things. It is north 55 degrees west. So now let's take a look at this example. An airplane, okay? An airplane flying at 500, you can read, but it has a bearing of 72 degrees. So that I can draw, okay? Here we go. I'm going to draw it right here. 72 degrees from north, 72 degrees. So let's call it that. 72 degrees. Okay. Now, after flying for 2 hours, okay, now keep in mind, it's been flying 500 miles per hour and it's been going for 2 hours. So it has flown 1,000 miles. The question is how far north and how far east. So it wants to know how far north and how far east. Okay, now you're in luck. This is just a right triangle, right? You've got 72 degrees, you've got 1,000 miles, and you've got trig functions on your side. All right, so the cosine of 72 degrees, right? That's the adjacent side over the hypotenuse. So you can use your calculator, figure out that the north direction is 309 miles. Okay, likewise, the sine of 72, which is the opposite side, east over hypotenuse. Sorry, it doesn't want to write. Anyway, you can figure out that east is 951 miles. Okay, for this example, a ship leaves port at 11 a.m. and has a bearing of north 13 degrees west. Okay, let me think about that. Oh, sorry. Okay, so this is north and this is west. So starting at north and 13 degrees west, that's the direction that the ship is going. Okay, how many nautical miles north and west? Okay, so north and west will the ship have traveled by 4 p.m.? I just realized I missed a very important part of this, which is that the ship sails 30 knots, okay? And knots are not difficult. Oh, sorry. Knots are just nautical miles per hour, okay? It's just a unit used by sailors. Okay, so let's see. 30 knots, and how long has it been sailing? Okay, so it left at 11, it's now 4 p.m., so 5 hours at 30 knots, so 150 nautical miles. 150 nautical miles is how far this ship has sailed. So this is a lot like the last problem, all right? You're going to use some trig, figure out the north and the west. Here's what it looks like. Cosine of 13 is north over 150, so the north is 146 nautical miles. And then the sine of 13, sorry, that looks bad. Let me rewrite that. sine of 13 equals west over 150. So west is equal to 33.7 nautical miles. All right, now, just a reminder, guys, I did this earlier, right? If you're not hearing clicks on my calculator, it's because I'm assuming that you're pausing and doing this stuff in your calculator on your own. Okay, so for this example, it says a plane is 300 miles south and 90 miles west of an airport. Okay, hold on. I got to think that through. There's an airport. Okay, pictures are going to save you. Now there's a plane. It's south 300 miles and west 90 miles. Okay, here's where the plane is. Right? There's an airport and there's a plane. The pilot wants to fly directly to the airport. So what bearing should he take? So I'm going to draw a brand new coordinate plane right here. This is where the plane is. The pilot wants to go straight to the airport, right? Which means I need to know that angle. That's the bearing that an airplane would take. Now, since this is directly north and south and this is directly north and south, do you guys see that this angle is the same one that I'm trying to find? Again, alternate interior angles. Okay, so with this side being 90 and this side being 300, I should be able to do the tangent of this angle. The tangent of whatever that angle is should be the opposite over the adjacent. And breaking out your handy dandy calculator, you should get 16.7 degrees. Okay, so I'd like you to read this problem and see if you can draw a picture, pause my video, and then come back. And I'm hoping you got a picture that looks something like this. All right, again, there's the lighthouse, and the angle of depression to those two ships are 4 degrees and 6.5 degrees. And the question is, how far apart are the ships? So we're going to call that Y. Okay, I'm going to call that Y. Now, there are two completely separate right triangles here. One of them looks like this, where this is 350, this is X, and this is 6.5. And then the other one, sorry for the repetition, I paused, is this and Y and 4. Now I need to make sure you recognize that this Y that I called Y is actually from the lighthouse all the way to the purple boat, okay? Because we'll be able to figure out the distance between them, right? If we figure out what Y and X are and then do Y minus X. Okay, so to figure out X, and I'm running out of room down here, so I'm gonna kind of come up here into the dotted lines. And hopefully you can see that the tangent of 6.5 is equal to 350 over X. So X is about 3072. Okay, likewise, the tangent of 4 is 350 over Y. So Y is approximately 5005. And when you find the difference between those two, you should get 1930 feet. Now, this is a rough problem, and I know I did it kind of fast, and that's why there are Zooms, or that's why in class you can ask me to do it in front of you.